Hello, good morning, good afternoon, everyone. My name is Sergio Gago. I come representing the quantum computing group at Moodys Analytics, and together with me, I have Karan Pinto. That I will let him introduce himself.
Hello, everyone. Good evening, good afternoon. My name is Karan Pinto. I'm head of growth and product at Terra, and it's very exciting to talk to you today about quantum and climate, Sergio.
Absolutely. So the goal today is try to give an overview of what is the state of the art in quantum computing and beyond, and how that can affect potential applications in climate, ESG, and many other sustainability elements that are required for our future, and ideally help you make an informed assessment on how far can we get by investing further in these technologies.
Absolutely. I think if you think about the climate crisis, there's three ways or three parts of solutions. You either stop, reduce, or you capture and store or reuse emissions. Now, if we had a genie, okay, and we rubbed a magic lamp and we wanted a magical solution or an enabler or a tool that we never had before to accelerate our progress on this climate front, that would truly be quantum. And as you know, Sergio, quantum is going to be a massive industry by 2035, estimated to be worth about $1 trillion USD in market value. And so hopefully today we can demystify this and bring to life what is this intersection between quantum and climate. So maybe we start off with just talking about climate in the first instance, right? Or quantum in the first instance, right? So quantum is truly a special paradigm shift. Okay, we're moving from a candle in terms of compute to a light bulb. Okay, how we manipulate it changes from putting the switch on and off purely to actually having a dial to turn up the brightness of the bulb. And this shift is very much akin to the shift that we had with moving to pre and post personal computers and pre and post the internet, right? Little did we know the magnanimous impact the internet and personal computers would have on our daily lives. So quantum should be thought about in that day and light, that humongous wave of innovation that will come to this technological enabler. Now, quantum is actually everywhere, right? It already makes many practical, highly valuable, and widely used things possible today, right? From the transistors on these devices that are connecting Sergio, you and myself, to the fiber optic cables and communication that help keep the world connected to each other through high-speed internet. Quantum is everywhere, and it's something that we're finding more and more practical uses of today as we accelerate its hardware advancement and technological progress. Over to you, Sergio, to maybe bring this to life of what is actually special about quantum and why is it so fascinating?
And especially why it is important for things like sustainability and climate change. The godfather or grandfather of quantum, Richard Feynman, say that if nature is not classical, if nature is quantum, then we need some kind of quantum device to understand it. And what happens is that in most of the complex problems that we face today as humans, whether it's in the financial industry, which is my case, or in the sustainability industry, these problems grow exponentially with the size of the problem. So our classical computers today have a ceiling of how far they can go. We have become really smart as humans, making them better, creating better algorithms, but still we always face that wall that impedes us doing better and doing things beyond what we can see. We can see this in every industry, from pharma to logistics to finance, and certainly materials, energy, and so on and so forth. Now, why quantum promises a better way or better solutions for this? It's based on the three kind of magical powers that the qubits, these pieces of information that quantum computers are made of. First of all, superposition, that allow us to model as many states as we want in exponentially less amount of qubits or quantum bits as we would need in a classical computer. Many of you would have heard about the infamous Schrodinger cat, can be live or dead at the same time. Now imagine we could model many different weather forecast scenarios at the same time, and then apply intelligent algorithms by using entanglement and interference, this kind of quantum properties, in order to find the right solutions that we're looking for. This means that we can get an exponential speed up for many cases that are current problems in the industry by using these three properties together. So sometimes we talk in terms of quantum computing and how that can affect some of the use cases that we will talk about in a minute. But quantum, as Karan was mentioning, is everywhere, right? It's not just about building algorithms, it's about communication. And lots is being said today about post-quantum cryptography and quantum key distribution in order to ensure safe communications in the quantum world. It's also about enhanced imagine and how we use that in medical devices, for example, and also sensing and metrology. Those are devices, that is a technology that has been around us for a long time and is far more evolved than computing per se. So it is the combination of those four pillars that help us get into what's called quantum advantage in the real world, in real world applications, and where the community is going.
And one really interesting thing here, Sergio, to point out is that, compute, imaging, and sensing and metrology, okay, all of these have direct climate tech related applications, right? So for example, classical sensors enhanced by quantum technology, or quantum sensors in a way, could help with emissions monitoring, specifically for methane, for instance, in leak detection and resolution in some way or form. So there's applications across the information science spectrum that would come from a climate perspective, and this is a really nice perspective to share. Yeah,
absolutely.
Yeah, just a few words. So I think I'm from Terra Quantum, and Terra Quantum is really looking to unleash the power of quantum technologies for good. And we have a quantum as a service offering across algorithms, compute, and safety. We recently raised one of the largest fundraising rounds from a Series A perspective of 75 million plus. And we really have an application-focused hybrid approach. And I think this hybrid approach is really interesting to have a near-term impact on an application perspective. So what does that actually mean? So if we look at the compute stack today, it is broken. Okay, you've got the classical side of things in terms of software and hardware that is completely separate to the quantum side of things. And there's a bit of a competition between the two, this fight between quantum and classical. Okay, you have quantum software that's developing very rapidly, but however, it is siloed from quantum hardware. And the question is, how do we bring these things together if we care about the end application, if we care about business performance, and we care about industrial scales, and we're agnostic of the technology, but more focused on the outcome? And well, that is hybrid, right? Hybrid computing means we complete the donut, right? We combine the best of the quantum and the classical worlds in some way to make possible real world impact through adding in quantum elements like quantum software run on quantum simulators, which are classical resources today that enable people to explore larger search spaces, find optimal answers to some of the most complex and high valuable problems that we have today. So I just wanted to bring that hybrid aspect to life, Sergio. And this is something that is applicable across industries, right? So we're working on quantum enhanced solutions all the way from chemicals in terms of working on fluid mixing and simulations in chemical reactors to optimize the shape of these reactors to make them more efficient through having better simulations of how these fluids mix together with each other. Okay, from a quantum simulation perspective, that's a very nice simulation problem combined with optimization. In the automotive space, we work on workflow scheduling, defining the right schedules for quality control inspections on the production line, okay, to make sure that these processes are more efficient. I will dive into a few in the energy and retail sector, as well as retail and logistics now. But I think it's really interesting that there's real world applications out there, right, Sergio, that quantum technologies are having a real impact on. Any thoughts on this?
And I think you're very right. And the fact of looking at it from a vertical perspective means that sustainability and climate solutions are pretty much everywhere. It's not just something that one industry specifically needs to tackle. And from the quantum side, that is the bridge that we may be able to cross. So today we know how much we have to decarbonize, or how much we have to stop spending, or how much we have to change on the fossil fuel usage. But we don't know exactly how in some of those cases, or we lack the technology to make the final replacement, especially in days like today's with the energy problems that we are facing. So quantum computers bring us the possibility in each of those industries to find those solutions, whether it is by optimizing those supply chains, or by optimizing those routes, or by optimizing the ESG scores of the portfolios that we are playing with. We think about quantum computers as a tool in a similar way that the computer that we saw on one of the first slides that helped us create a whole new industry and a whole new mindset on how we think about this, but in a way that's very, very embedded in each of these industries and beyond on this quantum and classical hybridization mode.
Absolutely. And maybe to bring to life how this tool is being used today, right? So for instance, in the energy and utility sector, we're working on predicting emission peaks in these biomass power plants, okay, waste to energy power plants. And by predicting these emission peaks more accurately using less data, what we can do is optimize the control settings of these power plants to make these dirty power plants a little bit more cleaner through enhanced analytics and intelligence from a hybrid quantum machine learning perspective. And in the shipping and logistics space, here we work on a very important commodity, LNG, which is, the heart and soul of our energy problems today. Getting this commodity to the right place at the right time through hybrid optimization is an incredibly complex problem. Okay, there's many different constraints from a real world perspective, like what time specifically to reach at a terminal, how much to pick up from a terminal, the specific details around contracts that make it a complex case and a good candidate where hybrid quantum optimization could really help make a difference.
Maybe to add some more details into that, that is a problem that today we can only approximate in a very simplistic way. Our trade-off is getting an approximation that resembles reality somewhat with some of our state-of-the-art algorithms, or find a better technology that allows us to have an accurate solution at speed. And that is the promise of quantum computing in this hybrid way.
Absolutely. Yeah. And to bring to life maybe another example, so in the transport and logistics sector, okay, there's many of these trucks that are used for route planning. And the problem is that when these trucks don't have any cargo on them, they unnecessarily are traveling wasted miles. And these are something called as empty miles, where the truck doesn't have any load and is unnecessarily traveling. So here we're working on an optimization or capacitated vehicle routing problem, okay, with different time domains to see how could you reduce the empty miles that this truck has. And this in some way means lesser empty miles and lesser waste, which is not only good for the environment, but it also means less traffic. It also means that you have more efficient schedules for your drivers, and it costs you less as a logistics company to actually deliver parcels to your home or get goods to a grocery store from the warehouses. And you've seen a lot of these supply chain based solutions as well, Sergio, right?
Absolutely. On supply chain is exactly the same situation. When you add all the constraints from the system, how can you do the same thing with a shipping cargo? Or when you have multimodal logistics. So every single use case that you can bring in this, if we can get this 20, 30, 40% improvement either on fuel reduction or optimizing the routes, then those are elements that work directly towards your ESG scores as a company.
Amazing. Yeah. So one thing that would be good to go into now is just to build that bridge to climate. Right? We've talked about some quantum applications. We've talked about quantum and its impact. Let's go into climate and let's see, what are the opportunities there for quantum technology specifically. I think there's a massive innovation gap, a 5x climate innovation gap that we need to avoid. Okay, for us to stay with our targets of being under 2 degrees Celsius, which is kind of like a point of no return. If we break that target, right, we're going to be in some trouble from a livelihood perspective, and all industries are going to be heavily impacted negatively by this. But to avoid this, okay, we have some numbers that keep us on track. Okay, now the amount of emissions we can emit today, okay, to be under this target is a fifth of the amount that we're actually emitting, okay, or planning to extract. And this is a very much imbalanced figure, okay. We want to be okay with the climate crisis, but we still want to emit so much, right? Whereas the number that we have to emit is much less. So how do we build or bridge this climate innovation gap that we have here? So there's many solutions, okay, across the board to understand, to help with this climate problem, okay? Everything from impacting the way we make things in terms of manufacturing, like cement, steel, iron, to the way we plug in terms of how we get electricity to keep our homes warm, and to power our lives, to the way we grow things to keep our bellies full from the agriculture that drives the productions that fill our plates, to the way we get around from a transport perspective, which we've talked roughly about today, to lastly how we live. Now, if you think of these 5 different aspects, there's a myriad of solutions, okay, that are already being used to make them more sustainable. Okay, and this is great work that's been done across the board with lots of VC investments to push forward climate tech infused innovation. However, there are barriers. There's limitations to how much existing technologies from a classical perspective can get us to. And maybe, Sergio, do you want to talk a little bit about those barriers of kind of why quantum is needed here, or how it actually comes into play?
Absolutely. So if we take the common factor across most of the elements in the top row, a lot of them are about how we simulate nature. Creating materials is basically playing with atoms and molecules at that level in order to do it in an efficient way. Improving agriculture is about how nitrogen fixes with oxygen and other molecules in the actual plant in order to grow crops faster or produce more yield. So a lot of that is simulating nature itself. However, simulating nature is an extremely complicated problem that our computers today simply can't do. Just simulating the molecule of caffeine, the most simple of them all, would require years and years of our current computers. We don't have neither space or computing power to do that. Imagine something like a paracetamol or any other, or a vaccine or any other compound like that, let alone how do we actually interact with photons coming from the sun to improve the energy efficiency of our solar panels.
Yeah.
The best we can do with our classical computers is approximate solutions. And we have become really good at doing that. And as you were saying, Karan, the state of the art is amazing, but the ceiling is right here. On top of that, we have Moore's law that says that our capacity to make our chips, our classical transistors and CPUs is getting into a halt on how better these processors can get. So all in all, we need a new technology that allows us to simulate nature in a better way. And even if we take cases like transportation or optimization that are not so much nature per se, but still we can model them in a way that on how nature works, then we can use these devices, we can use quantum computers in order to model those solutions faster, better, in a more accurate way. This is true for industries like pharma, giving them a bump on how they can create new drugs or vaccines, and definitely useful for our climate challenges like the ones you were mentioning here, Karen.
Yeah, absolutely. And I think that the why quantum question is such an important question for people to get. And I think it's not only from as you mentioned, like a limitation on the compute perspective with Moore's law and, us not being able to get any better and faster from a compute perspective, but also I think the load that comes from the top, right? You've got explosion of data with big data across all of these problems that you see here and solutions, lots of data where the volume, veracity, variability is increasing. It's pushing down on the models that help us get some kind of intelligent answers to make good decisions, to make good choices. And these models, as the size of these models increases linearly, okay, with more variables, more constraints, more possible, more kind of aspects incorporated within the model, the space for potential solutions or the possibilities grows exponentially. And as
Exactly.
this aspect of the drivers of value are not only just, I think, your more optimal solutions, but all and the way the ones that you talked so nicely about, which is the ability to simulate, but they also sit across these three types of problems, which is optimization, machine learning, and simulation. So there's a little bit of machine learning and optimization in there as well, in addition to the simulation one that you touched on so nicely about. Yeah.
Absolutely, and I think is one important point to make is that it's not either or solution. So quantum computers come to help specific problems and support and leverage already existing technology. So we are standing on top of giant shoulders in a way. We are trying to improve what machine learning and AI has been doing for some time, and what other models are around there. And you made a really important point, that is the vast amount of data that we have today. Now we have the capability of putting IoT devices almost all around the world, and then model and find patterns that are super accurate with what is happening with the Earth. But we cannot compute all that. We cannot find the right optimizations or the right combinatorial problems in order to take it to the next level. And I think that is where a new set of technologies are needed, by hybridizing everything at the same time. Hence the new super active field of research on quantum machine learning.
Yeah. Amazing. So just before we kind of plug the thesis and the solutions that we have for quantum and climate, right? I think it's important to contextualize the nature of the problem, right? Okay. The climate crisis is very systemic in nature. So you need to understand the second and third order consequences of a potential solution that you plug in. Timing really matters here, right? We need to act now if we want to do something that has an impact in 5-10 years, okay? Because the time for that impact to trickle down takes a while. There's great pressure from different types of bodies, not just the government, but different smaller organizations to try and get people to act at scale, get organizations to act at scale towards driving more sustainable solutions. And we see this reflective in some way or form by an increasing carbon price. Like the price of carbon is increasing, but it's still cheaper to emit than it is to actually have a more sustainable solution. So those economics we need to change. And there's a lot of greenwashing out there, which we have to be very wary of, where when we're analyzing these things, we should do a thorough end-to-end life cycle analysis to see over the net perspective, does this actually make a positive difference or a negative difference? And does that kind of equation change over the longer term as the tech matures more and the cost curves become more and more attractive? And that's something to be a bit wary of from just finding these solutions and bringing them to life. So we have a thesis that's available, which I did together with a collaboration partner of mine called Nicholas Lee, who works at Fujitsu as well. It's very powerful. We have a little bit of an organization called Entangle Climate, just purely focuses on, quantum tech for climate positive outcomes, and it's available to read online. And maybe I'll just summarize some of the key takeaways or the overview of the thesis there, which you can dive into at your own free will. So the way we look at the opportunities for quantum tech and climate sits across these 7 pillars, okay, which is how could quantum tech help with climate mitigation across nature-based solutions to improve the efficiencies of buildings and cities, to make our energy more sustainable and renewable and accelerate that transition, to help us have more efficient agricultural methods, as well as sustainable ways to produce fertilizers, and then industry and transportation. So these are the kind of key pillars, and these pillars have within them many use cases. Okay, and I've pulled some of these use cases aside to maybe talk about them and bring them to life a bit more, which we should dive into deeper now, Sergio. Yeah, so one use case that I'll bring up is, so the green machines that actually power the renewable revolution, the solar and the solar panels and the wind turbines. Okay, there's two opportunities here specifically from a quantum tech perspective. One is a material science one. Okay, is how could we decouple these green machines from fossil fuel based materials? How could we find more sustainable materials that improve the life cycle of these solar panels and wind turbines, that once they've been used, we could potentially reuse them, or don't have a disastrous process to actually recycle them. Okay, that's a one very powerful one to make these ones more sustainable. And the second one is, in some way, how do you improve the operational efficiency to get more generational capacity out of these solar panels and wind turbines? Okay, the way you position them, the way you actually place them on a field. For example, a facility location allocation problem for wind turbines is one that could have a big difference in terms of improving the generational output of that wind farm, just by purely positioning them in the right direction, in the right kind of configuration. And that again is a quantum optimization problem, which is really interesting. There's some energy storage based innovation. Do you want to maybe touch on, batteries? And I think you like simulation, so maybe you can talk a little bit about that, Sergio.
Yeah, so I think in every single part of the value chain or the supply chain of energy, there are optimization cases where you can actually get efficiencies at scale when we're talking about global societies. So we start from the point you were making on how can we make better solar panels by improving our materials, and then how do we actually distribute that? Which are the best roofs that provide the most efficiency, or the best hills to get the best windmill efficiency? Those are problems that you run every once in a while, but still could take a very long time if you want to get the most accurate model, especially when you're trying to do weather forecasting. Now, again, as humans, we've become really good at weather forecasting, but we can only work with a certain amount of scenarios. It's very similar to financial forecasting as well. We can only hold so many scenarios at the same time. But when we get into the superposition and interference powers of quantum computers, then we can suddenly go further and play with models that require less data sets, but at the same time work with more features. And when we advance one step further in the value chain, we enter in what's called today the consumer and producer economy, the co-producer economy, that many companies, many electric companies in the world are tapping into. We have now hundreds of thousands of roofs that can be producing both solar and wind energy. But that, of course, affects how much we forecast our energy production as the demand changes dynamically over time, and there is no day like the other. So how do you optimize that grid, and how do you make sure that the energy that my roof is producing today is being used by my neighbor and not by someone 100 miles away? Because no matter what we do, energy storage and energy distribution is always going to be expensive, or we'll have losses. So by optimizing those cases and picking carefully the locations where we do this, then we can actually have an almost self-sustainable city going into the area of smart cities and stuff like that. And if we can do that at scale, not just in a small neighborhood, then it means that the savings on energy production and consumption and losses in the circuit can be massive.
Yeah.
No matter what, we will still need batteries to store excellence and to store this energy. And that is, again, back a chemistry problem. is simulating the nature problem. So new materials together with quantum technologies can help us iterate further and faster on identifying those materials and those batteries that are needed not only for our houses, but also for our cars and any new EV economy that we get into and beyond.
Yeah, absolutely. And I think there's many cases that scream why quantum, or yes, I need quantum, right, across the energy value chain. And you really nicely cover the prosumer facilitation, right? To facilitate prosumers at the end of the chain is paramount, and that's a complex problem from an optimization perspective. But if I add some more, earlier down the value chain, right in the center, you've got the balancing mechanism problem, which is actually solved every 15 minutes, is how do you match supply and demand across the grid in a sustainable way,
And in real time.
In real time, right? I think that's a really kind of exciting problem right at the heart of it. And then if you go behind and further behind, you have the unit commitment problem. Is how do I kind of organize my generational capacity, putting it on and off given the load I have further on. And that again has this clear link to sustainability, because you don't want to be putting your dirtiest assets on and off all the time, because it takes up more emissions and such. So how you phase that unit commitment problem out has a deep coupling with the balancing mechanism and then the certainties across the grid. So anyway, like you see, the whole uncertainty associated with renewables pushes forward the need for quantum technology-based solutions here.
Exactly.
One question we've got a lot, Sergio, is quantum compute more efficient than classical compute? And this is probably something we should spend some time on, because my key message here is that quantum could let you do more with less, and it's never quantum or classical, it's and you need to look at it on a case-by-case basis. But what are your kind of thoughts here in terms of compute efficiency and the energy that it uses as from a data and power perspective?
Right. I think I would get back to one of your first slides where you showed the candle and the light bulb. The situation today is that we have very early stage light bulbs that last for less time than the candlelight and are not super efficient, and our electric lines are still like in the Edison times. But that does not mean that we see a future where everything is electrified and everyone switch on the lights in the room, and immediately, almost like magic, you get the right bats into your house to power that light bulb. So we are in a very interesting era where we're creating some new industry completely, where we see specific use cases for very urgent matters like this one, but also beyond. Right? There are many companies, many institutions, many governments investing heavily in quantum for reasons beyond climate. Cybersecurity being one of the big ones out there. Now, quantum computers are still getting mature, and depending on who you ask, you will get this quantum advantage sooner, later, it depends, right? There's no clear consensus on that. But that does not mean that you cannot get business advantage today by doing several things. The first thing is how do we think about quantum per se? A lot of people think that they will have in the room or in their company one of those big fridges doing calculations, and then someone will put punch cards in there and get a result. And it is very far from it. Right? You were saying that it's always hybrid. You get classical data, classical information from your own laptop being sent all the way over to a quantum computer to do a very specific computation. So these devices serve for only a handful of problems. They are not super universal. They can do any computation, but it's only a few types of problems where they excel, where they do better than any other classical computer. And those we've been discussing in the last several minutes, right?
Absolutely.
So in the same way that you take your motorbike to go to the office and rocket to go to the moon, you wouldn't do it the other way around. Now, one of the things that a lot of people is doing is mixing different technologies, like hybridizing what quantum chips and simulators can do, all the way with our state-of-the-art algorithms and doing also quantum-inspired type of methods that help us find this advantage while we make this hardware better. So we have small and short-term light bulbs today that are definitely not the best in the world, but we know that as hardware evolves, and it's an engineering problem, it's not a physics problem, we're going to be able to solve all of these problems at scale.
Absolutely. Yeah. And I think there's one interesting concept that we should dive into now around the quantum green premium. Okay. It's like if we take the example of capture tech innovation. So this is capturing carbon or methane and reusing it in some way or form or storing it under the ground. Okay. Today, it is more expensive to capture and store it than it is to emit it, right? So the economics don't work out today. However, quantum technologies could help us find new materials for capture of carbon and methane that make the dynamics of this price equation different. Okay. And there's a way where, we want to make this quantum powered alternative, whatever that might be, more commercially attractive than the dirtier current solution. Okay. And that could be through the right incentives. It could be through accelerated tech learning curves. But practically, it could also be through the impact or the value that a quantum powered solution creates is so much more than the existing dirty classical solution that the value in itself pays for the price of the quantum technology based approach. So that's a really interesting kind of quantum green premium concept. And we've actually done a little bit of an analysis where this green premium lies across sectors. And I think this is important, not just from a sustainability perspective, but this is important from an industrial application adoption perspective of quantum tech powered solutions, that we want to be able to make it very easy from a expertise, from a use perspective, to take advantage of this great new tool, this light bulb that's coming to the fore, and make that advantage practical, where you see a certain kind of return on the investment that will grow if you do it in the right way and form today. And so I think, that's an interesting adoption perspective. Any perspective you have on that, Sergio, from a Moody's analytics, maybe?
So from our side, it is a lot about how do you manage the risk in your supply chain, manage the risk in your providers, and manage an optimal portfolio when you think about ESG considerations. And then all drills down into these industries and how they are managing the respective actions for climate. So on that side, capital deployment is at the base of everything we do, and our responsibility in order to be able to manage all these scenarios as well. So it's kind of a new column out there in terms of R&D expenditure, capital deployment, and investment in general. I think we have to be very specific on which are the low-hanging fruit cases, so we can see and demonstrate the world that this is actually possible. And you're making a really good point on energy and transportation cases that have a lot of actual touchable use cases with quantum today, right? With route optimization and energy vehicle hub placement and cases like that. And then making sure that we pave the way for new cases as the technology evolves, but making sure that we do things today and that we create a lot of awareness, not only in forums like this one, but also in the rest of industries. So when the time is right, the investments that we make are tailored towards all those domain specific use cases that now can happen, can be done, and there's no excuse because now the technology exists.
Yeah, absolutely. And I think this is where, I bring up our call to action, right? I think there's a great the image of Garrett McNamara, okay, this big wave surfer surfing a 100-foot wave off the coast of Nazaré in Portugal. Yeah. And the question to the audience is that, look, you could be a spectator, okay, who loves watching these massive waves and people watching those waves, or you could be like Garrett. You could try and surf that wave yourself. And there's very few waves that come like quantum technologies. And surfing that wave in the right way or forms is that you end up okay at the end of it, on the right side, rather than under it. All depends upon the kind of the decisions you make and how easy you make it for you guys to use it. So yeah, maybe we do a little bit of a conclusion, Sergio, and wrap up
Yeah.
thoughts. So I think just key takeaways. I think quantum tech is real today, right? It's really moving from sci-fi to sci-fi. You can use it, you can touch it, you can see quantum computers out there. You can see applications coming to life. Impact from a positive perspective is possible, okay? And we really need first principle based innovation that's application focused and hybridized in some nature for it to be realized today. And then lastly, now is the time to act. Yeah, this is a generational defining technology. It's like that point where you knew the internet was coming and you knew the personal computers was being developed, but you didn't want to build your Shopify or Google because you couldn't understand it, or you were, under the wave rather than on it. Maybe over to you, Sergio, for some concluding thoughts.
Yeah, I think you summarize it very well, right? But many governments are investing heavily in this technology from a sovereign perspective, mainly because of cybersecurity. We know that it's a technology that may have big impact in there. Many companies, such as Moodys Analytics, see it as a disruptive technology for our business and how we provide value to our clients. Many companies like yours, Karan, see it as an enabling technology for many of these use cases and many of these companies. But we have a big dark cloud on top of us. That's the point you were making before, Karan, on how many degrees we can keep gaining in our Earth operations. So now we have everything we need. We have the willingness, we have the technology, we have the investment capabilities. Now we just need to join forces and make sure that we use this technology to keep evolving and keep creating value, but in a sustainable way. And I think we can do that together. We need to keep evolving the technology and making it more mature, hybridizing it, and finally taking it to the markets. So I think I would just finish with a call to action, as Karan was saying. We can make ourselves available, Karan from Terra Quantum, myself, Sergio from Moodys Analytics, for any further questions or discussions. There's a lot to be done, a lot to be said, a lot to be researched, especially when you mix climate, weather modeling, ethics as well, on anything that's related to new technologies. But as you can see, we are passionate. We have the resources and the means and the problem. So we just have to act on it. Thank you very much, everyone, for listening.
Thank you.
Okay.